Hey guys, now we are going to solve question number 29. Let's see what the question says. 2 moles of an ideal monoatomic gas occupies a volume V at 27 degrees Celsius. The gas expands adiabatically to a volume of 2V. Calculate A. The final temperature of the gas. B. Change in its internal energy. So let's just start, which are given to us. So it's given us that it's a monoatomic gas. So the value of gamma is 5 by 3 and temperature is given to us as 27 degrees Celsius. So we will convert into Kelvin by simply adding it 273 to it. So T1 comes out to be 300 K. Now it is also given to us that is V2 by V1 is 2. So we will take advantage of the equation T V gamma minus 1 equal to some constant, and similarly T2 V2 gamma minus 1 equal to T1 V1 gamma minus 1. Now let's see the ratios of T2 by T1. Simply take this term and put it in the denominator of T2, and similarly take the V2 term and put it in the denominator of V1. Once you will do this transformation, T2 by T1 is equal to V1 by V2 raised to the power gamma minus 1, and the value of V2 by V1 is given, so the value automatically for V1 by V2 comes out to be half. So just put this value over here, and gamma is also given to us, so also put the value of gamma here. So the thing which you will be getting for T2 by T1 is 1 by 2 raised to power 5 by 3 minus 1, and on further solving you will be getting 1 by 2 raised to power 2 by 3, and it can be written like this: 2 square, which is under cube root of cube root, so it can be simply written as cube root of 4. And when we are going to solve this, this is 1 upon, this is 1 upon cube root of 3. This comes out to be 0.63, and the T2 is calculated by 300 into our calculated value, that is 0.63 here, as you can see, and it comes out to be 189 Kelvin. Then the value of delta U is calculated by F by 2 into N into R into delta T, and N is given to us, R is 8.3, delta T is 111. Now 2 gets cancelled out, and when we are going to solve it, we are going to get the value of delta U minus 2.76 kilojoule.